All right, so we're going to continue solving quadratics. Today we're going to review how we solve quadratics using square roots, also by completing the square and using the quadratic formula. Before we get going, how many Sour Patch Kids are in this bag, do you think? Okay, so last time in our last lesson we started solving quadratics. Remember, quadratics solutions are where they cross the x-axis if they're real, and sometimes you'll get non-real answers. And this will help us with higher degree polynomials. So as we get into our future lessons on polynomials, we'll need these tools. So we already did the first two, graphing and factoring. Today we're going to focus on these bottom three. And remember, we're trying to find this if they're real. So sometimes they won't be real though. Okay, now solving quadratics using square roots. This is great, but it only works for certain cases. So one thing to keep in mind, this only works when there is no bx term. If that's the case, then try this, okay? Step one, you're going to isolate the x squared. Then you're going to square root to get rid of that square, and then just write your answers. This should be write your answers. There will be two of them, okay? Okay, so how does this work? Well, you're going to isolate the, notice there's no bx, so we're going to isolate the x squared. In order to do that, solve like any other one, add 64 to both sides. This would give me x squared, these cancel out, equals 64. Okay, and then you would say, all right, now I'm going to take the square root, both sides. That would give me x equals, and then this would now be 8, right? But remember, when you take the square root, there's two answers, so it's plus or minus 8. And so my two answers would be 8 and negative 8. You can just leave it as plus or minus 8, that's fine. Okay. So, again, solve like any other one. Let's just see a few other ones here so you get used to how this works. I would have x squared, these cancel out, equals 18. Okay, now I'm going to take the square root, and I say, all right, that means x equals, okay, well, the square root of 18, remember, is square root of 9. You want to break that apart because that's not a nice number. So I'm going to break it apart in simplest radical form. So that would give me 3 root 2. So my answer would be here plus or minus 3 root 2. Make sure your answer is always in simplest radical form if it's not a perfect nice number, right? Okay, so how do some of these other ones work? So same thing, notice no bx term. I'm going to solve this, isolate the x squared. Okay, I get 2x squared equals negative 162. Divide by 2 first, I get x squared equals negative 81. Okay, now I'm going to take the square root of both sides. So I would get x equals, now I want to break that apart, right? I got square root of, I got to get rid of that negative, right? Negative is going to be I. And then this is going to be 1. I guess I should write. This is I here, and this is going to be 9. So my answer is plus or minus 9i. Okay, so if you were to graph this quadratic, it would not cross the x-axis because both roots are imaginary. Okay, let's just do another one. Make sure we're kind of on the right track with these. Subtract 60. From both sides. This gives us 4x squared equals negative 49. I'm going to divide by 4, divide by 4. This is not a very nice number, but I noticed that both of these are perfect square roots, both the numerator and the denominator. So if I'm taking the square root, I guess I should write this first. So now I'm going to take the square root. I could say, all right, well, this is plus or minus, and both of these are perfect squares. So, and I also have that negative in there, so I have to think that's an I. Okay, so I've got this is I, and this is going to, you could take the square root of the top and the bottom, so this is going to be 7 over 2. So I'm going to write plus or minus 7 halves I, right? Square root of 49, square root of 4. And that's how you solve quadratics using square roots. Remember, this only works if there's no bx term. Okay. All right, completing the square. Here are the steps. You can always come in on that. You're going to move the c to the other side. If there's an a, something other than 1, like a 3 in front, then you're going to divide everything by 3. You're going to add half a b squared to both sides. This creates a perfect squared trinomial. You're going to factor that, and then you're going to take the square root and solve. This you should have done last year, so you might recall this. So we're going to move that c to the other side. So I'm going to move that 45 to the other side, so that's going to be negative 45 to both sides, and I'm just going to... Okay, now when I do that, I'm going to put a blank because I'm going to create a perfect square trinomial. Now, in order to do that, I'll have to also add the same thing on the other side. So I'm going to put a blank over here as well. Maybe I won't put that plus sign. Okay, so now what do I add? In order to create the perfect square trinomial, you're going to do half of this. So 18 over 2, and then you're going to square it. So you're going to go, you can do all of that in your head. You're going to say half of 18 is 9, and then you're going to square 9. So that's 81. So I'm going to write plus 81 here. Now if I add 81 to one side, I have to add 81 to the other side to keep it balanced. So that's kind of an important thing to keep in mind. Okay, so now this right here on the left, you can factor this. If you do, it will always be x plus 9, or these two numbers, I should say, will always be the same. Okay, so notice, what are two numbers that multiply to be 81 but add up to be 18? 9 and 9. Now, it says you want to write it as, if you look up here, it's going to be x plus something squared. And that's because these will always be the same. So x plus 9 times x plus 9 is x plus 9 squared. So I'm going to actually write that instead. And this will always be the case because it's a perfect square trinomial. So whenever you complete the square, you should be able to go from here to here. It will always be a perfect square. Here's also a hint. When you complete the square, this number right here will always be half of this. Okay, so that's a shortcut. Then you don't have to factor if you want to use that. Otherwise, factor it and just write it in the squared form. That's fine. So now this then is 36. Okay, now you're going to take the square root of both sides. Okay, so now I'm going to get x plus 9, the squared and the square root will cancel, equals plus or minus 6. Okay, now I need to solve both equations. Okay, so I got plus or minus 6, but I got to get the x by itself, so I'm going to subtract 9, subtract 9. Now where's that 9 going to go? You're just going to write it in front of the plus or minus. So you're going to write x, these cancel, equals negative 9 plus or minus 6. That's a really ugly plus or minus sign. Okay. Now, what are your two answers? What's negative 9 plus 6, and then what's negative 9 minus 6? So you want to think of that. So negative 9 plus 6 is negative 3. Okay. Then negative 9 minus 6, that's negative 15. Okay. And those are my two answers. Let's do another one. Okay, so solving quadratics by completing the square, we want to move the c to the other side, so that means I'm going to get this to the other side. So I want to add 87 to both sides. So I'm going to have 4x squared plus 16x, and then this is going to give me equals 84. Now notice I have a leading coefficient of 4. I got to get rid of that before I can complete the square, so I have to divide everything by 4 on both sides, every term. So this is going to be x squared plus 16x divided by 4 is 4x equals, and then 84 divided by 4 is 21. Now I'm going to have to complete the square, so I'm going to put a blank on both sides. So I'm going to complete the square by saying half of 4 squared. So 4 divided by 2 is 2. Square that, I get plus 4. Okay, I'm going to add that to both sides. All right. Now I'm going to write this in factored form. It will be x plus 2 times x plus 2, which is x plus 2 squared, and this is 25. Okay. And then take the square root. Okay, now once again, this one's going to be a nice number, which doesn't always happen, but just so you're aware of how this works. Okay, so now I'm going to subtract 2. And remember, when you write this, I'll write it over here. We're going to write that negative 2 is going to go in front. So this will be negative 2 plus or minus 5. And then write your two answers. Negative 2 plus 5 is 3. Negative 2 minus 5 is negative 7. So those are my two solutions. Okay, I'm going to do one more, and then we're going to stop this video there. Okay, solving quadratics by completing the square. Again, move the c to the other side. Now this time the bx is on the other side, and the c is on that side. We got all kinds of weird stuff going on. So I want to move, I'm going to subtract 88. Now I need the bx term, I need this to go over here, so I'm going to have to subtract 10x. I got x squared minus 10x equals negative 88. Okay, now I'm going to put a blank there, complete the square. What's going to go here? Remember, half of negative 10, and then I'm going to square that. So that's negative 5 squared, which is positive 25. It's always going to be positive. Okay. Then I'm going to factor this. This would be x minus 5 times x minus 5, or x minus 5 squared. Okay, and then this would be negative 63. Okay, take the square root. Square root. This is going to be x minus 5 equals, all right, well, plus or minus. Now we've got this situation going on here. So we've got negative 63. So what is that? Well, we've got negative 1 times biggest perfect square that goes in there is 9, but it's also that negative. So I got that I got 3, and I got that 7. Square root of 7 is not going to change. So I'm going to write plus or minus 3i root 7. And you can just do one more thing here. Add the 5 to both sides. I'm going to add 5 on that side too, right? So plus 5. So when you do this, you're going to write your answer as 5 plus or minus 3i root 7. And you can leave it like that. That means 5 plus 3i root 7 and 5 minus 3i root 7. Okay, so that's how you solve by using square roots and completing the square.